All right, so now that we have talked about all the different ways that we can take derivatives, now we can actually use that as our first step. So from here on out, anytime that you take a derivative, you're going to want to simplify it as much as you can before moving on because it's only going to be the first step in our process. So that's going to bring us to increasing and decreasing functions. When you were in your college algebra class, that was before this one and everything, whether it been pre-calculus, college algebra, math 112, whatever it was, you talked about increasing and decreasing functions in terms of algebraic ways on how to do it. One way was by looking at a graph. We could see that our function was increasing on the entire interval. So, like this example here, if you think about a positive slope, we're increasing everywhere. Here, we're kind of decreasing everywhere. So if it goes up from left to right by looking at the graph, we call it increasing. If it goes down left to right, we call it decreasing. Now we kind of want to talk about this in terms of calculus, in terms of derivatives. So on the intervals where f prime of x is greater than 0, our function will be increasing. In other words, the slope of the tangent line is positive. On the intervals where f prime of x is less than 0, our function will be decreasing. The slope of our tangent line, this should be positive right here, or it should be negative. Now, how do we find the where spots where it may cross from increasing to decreasing or decreasing to increasing or constant, however we want to talk about it? Well, that brings us to critical numbers. So critical numbers are those numbers which we call C that are in the domain of our original function f, that when we plug it into our derivative, so f prime of c, it either has to equal 0 or f prime of c does not exist. So that means that our function is undefined at those values. The way to find our critical numbers is the following. We take our derivative, we set it equal to 0 and solve. That finds our first case f prime of c equals 0. We then looked and check our domain of our derivative. If we have any places where it has division by x, in general, log functions, square root functions, and finding both of those domains, those are places where it may not exist at. And keep in mind, here's a little side note. If it does not exist in the domain of f of x, it is not in f prime of x. If it's not in the f prime of x, if it's not in the original domain, it can't be a critical number, so therefore it can't be inside of f prime of x. If the original function is a rational function, then you must set the denominator equal to 0 and solve as well. This is also a critical number, depending on how it works in our derivative. It could be a place where this could be a test value. Some softwares consider it a critical number, so we just have to be aware of that some call it a critical number, some call it a test value. So we're told in this direction set, find the critical numbers of the given functions. Well, in order to find the critical numbers of our given functions, what we have to do here is we just simply have to take our derivative. So y prime is equal to 18 minus 18x. We set it equal to 0. 18 equals 18x. Divide. So our only critical number in this first one is a 1. Is x equals 1. Finding critical numbers is really that easy. Take your derivative, set equal to 0, especially when they're polynomials here. We'll worry about others in a second. For the second one, y prime equals 2x squared minus 2x minus 24 equals 0. If you factor out a 2, you get 2 times x squared minus x minus 12 equals 0. So 2 times x minus 4, x plus 3 equals 0. So x equals 4, x equals negative 3. So in this case, we have 2 critical values. Noticing a trend, whatever the degree of our original is, we always have one less than that in terms of critical numbers. So y equals 2x plus 17, y prime equals 2. 2 is never equal to 0, so there are no critical numbers for this one. For the fraction here, understand that y equals x minus 7 divided by x plus 3. X cannot equal negative 3. It's not in my domain of the original, so it does not exist. So keep that in mind. Y prime is low, d high minus high, d low over our bottom squared. So this is x plus 3 minus x plus 7 over x plus 3 all squared, or 10 over x plus 3 all squared. So that's our derivative. Now, if we set this equal to 0, we get 10 equals 0. Not possible. Keep in mind, some places will consider this x plus 3. The problem with it being a critical number is it's where it does not exist. So this one does not exist there. Therefore, and it was not in the original. If it's not in the original, some softwares will say it's not a critical number. Some will say that it is a critical number. So you're just going to have to see where we're at with that. By definition, it is a critical number. So I would say x equals negative 3 is our only critical number. Now we have a product rule. So y prime equals the square root of x squared minus 4 plus x times 1/2 times x squared minus 4 to the negative 1/2 times 2x. So we're going to have the square root of x squared minus 4 plus x squared over x squared minus 4 to the 1/2. Simplifying, we get x squared minus 4 plus x squared over the square root of x squared minus 4, which is equal to 2x squared minus 4 over the square root of x squared minus 4. We set this equal to 0, so 2x squared minus 4 equals 0. 2x squared equals 4, x squared equals 2, x equals plus or minus the square root of 2. Make sure you use plus or minus when you solve that because you took the square root. The other place is x squared minus 4 cannot equal 0, x cannot equal plus or minus 2 by the denominator. So just keep in mind, this is where it does not exist at. So therefore, these both are our critical numbers. So that's if we were just wanting to basically find critical numbers. Well, we got to know, what are we going to do with critical numbers? Well, the whole thing behind critical numbers, they're like endpoints of intervals. They kind of give us stopping points where we switch between something. So if f prime of x is greater than 0 for each x in the interval, then f is increasing on the interval. If f prime of x is less than 0 for each x in the interval, then f is decreasing on the interval. To determine the intervals where the function is increasing or decreasing, you must set up a number line and test numbers to the left and right of all critical numbers in the domain of the function and the derivative. All right, so we're told find the interval where the functions are increasing. So our goal is to do that. So in this first case, y prime equals 3. We set it equal to 0. Well, 3 doesn't equal 0. Well, let's think about what is the graph of our function here look like. Sometimes finding the derivative does not tell us enough information, so we need to look back at the original function to be able to see what's going on. So 3x plus 6 looks like this. Well, that looks like an increasing function, so it's increasing from negative infinity to infinity based off of the graph. Sometimes we have to look back at this. So let's look at this second example. Y equals 2x squared minus 4x plus 11. Y prime is 4x minus 4. Set it equal to 0. 4x equals 4. X equals 1. That is our critical number. So now we got to come up here and follow this process here. Well, easiest way to think about this process. Create a number line. Put all of your critical numbers on it. I like to circle my critical numbers because I'm going to pick a value to the left and to the right of each one of my critical numbers. In this case, I only have one. I want to know what happens y prime at 0 and y prime at 2. I'm not really worried about the value as much as we are worried about the sign. Is it positive, negative? What's going on there? So we plug 0 into our derivative. So 4 times 0 minus 4 gives us negative 4. So above that 0, we'll put a big negative sign. At 2, 4 times 2 minus 4 is 8 minus 4, which is positive 4. I'm going to put a plus sign. Now, we were told to find where is it increasing. So this problem right here is increasing on the following interval. A critical number will only occur at the points where we go, or let me phrase that. Eventually, we will talk about relative max and mins, and it has to occur at critical numbers. Get a little ahead of myself here. When we talk about intervals of increasing and decreasing, the only numbers that are allowed are the circled ones. So since my positive was over here to the right, it's going to be parentheses 1 to infinity. All increasing, decreasing intervals will always be parentheses. I don't care what anything else happens with it. So this next one, y prime is going to be 4x cubed minus 8 equals 0. 4x cubed equals 8. X cubed equals 2. X is equal to the cube root of 2. So very similar. We come over here. We put the cube root of 2 on our number line. If you really want to know exactly what this is, the cube root of 2 is approximately 1.26. So I could again pick 0 and I could pick 2. So we need y prime at 0, y prime at 2, y prime at 0, 4 times 0 cubed minus 8 gives me negative 8. Minus, plug in 2, 4 times 2 cubed minus 8 is 32 minus 8, which is 24. So it's positive. So therefore, this one is increasing from, sorry, I had something else in my head. Cube root of 2 to infinity. Don't think that they're always going to be on that same right interval. That's just by coincidence that that's happening. For this one, y equals 2 over x squared plus 6. we get y prime is equal to low d high minus high d low over the bottom squared. So minus 4x over x squared plus 6 all squared. Set that equal to 0, we get x equals 0. So on our number line, we have 0, so you can plug in -1 and 1. Now keep in mind for this problem right here, our denominator is always positive because it's squared. So the only thing we really have to work about is that numerator. So minus 4 times -1 over positive is 4. So it's positive. Plug in 1. -4 times 1 over positive gives us -4. So it's negative. So in this case, we are increasing from -infinity to 0. So on the next problem, y equals negative square root of x plus 7. So that means that y prime is equal to minus 1/2 times x plus 7 to the -1/2. So -1 over 2 times the square root of x plus 7. Set that equal to 0. There's no place in the numerator that gives us 0, but our denominator says x equals -7. Now keep in mind that we cannot plug in a value less than -7 because of our domain restriction up here. So if we plugged in 0, we would have into our derivative. So we would have -1 over 2 times the square root of 7, which is negative. So therefore, this one is increasing nowhere. So for this one, y prime equals 1/2 times x squared plus 14 to the -1/2 times 2x, which is x over the square root of x squared plus 14. Set that equal to 0, and you get x equals 0. We could plug in -1 here. And we could plug in 1 into our derivative. So -1 over the square root of -1 squared plus 14 gives us -1 over square root 15. So it's negative. 1 over the square root of 1 squared plus 14 gives us 1 over square root of 15. So it's positive. So therefore, this one is increasing from 0 to infinity. For this one, y equals x plus 2 over x minus 6. So y prime equals low d high minus high d low over the bottom squared. So that means y prime equals x minus 6 minus x minus 2 over x minus 6 all squared, which is -8 over x minus 6 all squared. So my critical number is only at 6. So when I plug in 7 and 5 into the derivative, -8 over 5 minus 6 all squared is -8 over -1 squared, which is -8. If you plugged in 7, you would get, -8 over 7 minus 6 all squared, -8 over 1 squared, which is -8, we get negative. So even though we got a negative and a negative, that sometimes will happen and everything. So in this case, it's increasing nowhere. This is an always decreasing function in terms of what we're given here. So we got to be careful about what we're given because it could affect things and everything.